Okay, in this video, we're going to talk about measures of dispersion. In the previous section, we talked about measures of central tendency. So we looked at different ways, there were four of them, different calculations for finding the center of a data set. So we had the mean or the average, the median, the mode, and the mid-range. In this section, we're going to talk about dispersion, which is the spread. So how spread out is our data set? And there are two measures that we're going to look at. One, super easy. The second one is much, much more involved. It's not necessarily difficult, but there's just a lot of steps to it, okay? But first, I do encourage you to go back and read your textbook, read the introduction to this section, because the author does a fantastic job of describing what's happening. So just kind of quickly, for the sake of this video, consider two towns. I believe they use Houston and Honolulu, but for now, we're just going to call them town one and town two because I can't remember exactly. Both towns have an average temperature of 75 degrees. So if you look at the temperature each day annually for the whole year and you average them out, you find the mean, you're going to see that both cities or both towns have an average temperature of 75 degrees. But that doesn't necessarily tell the whole story. For town one, the temperatures go anywhere from, let's see, I think it was 60 degrees to 90 degrees. But town two goes anywhere from 40 degrees to 100 degrees. So at the lowest or the coolest time of year, town one has a low of 60. During the hottest time of year, a high of 90. And that averages out to be 75 degrees a year. However, town two has much lower temperatures for their cooler season. They get lows of 40 in the 40s, and they have higher temperatures in their hot season. So temperatures around 100. Again, this averages out to be 75 degrees. So what we're going to look at for the sake of this video is this information right here. We want to look at the spread of the data set. Okay, so the first measure we're going to talk about is the range. The range is the difference between the highest and lowest data items. Okay, so one thing that you do need to make sure you're aware of is the range depends on only two data items. So only two data items in the set are considered. So you only look at the highest and the lowest. So if we looked at town one, the range for the temperatures throughout the years would be the highest of 90 minus the lowest of 60, or about 30 degrees. So the mean temperature for town one is 75 degrees, but there's a difference of 30 degrees between the cold and the hot season. If we were to look at then town two, the highest temperature is around 100. The lowest temperature is around 40, so they have a range of 60 degrees. So this tells us while these two towns have the same average temperature, the spread throughout the year is way different. There's a range of 30 degrees, and then there's a range of 60 degrees, depending on the town you're in. We don't really need the degree symbol there, but so there you have it. So when you're dealing with a situation like this, if you're only looking at two data items, it's a rough measure. It's something quick that we can look at, but it doesn't necessarily tell the whole story because, again, we're only looking at two data items. Okay, so for example, here we have the numbers 4, 2, 11, and 7. All right, so if we wanted to find the range, we don't even really have to do any work. We can just take a glance at this data set and find the range. But for the sake of the notes, you take the highest minus the lowest. So we would take 11 minus 2, and we have a range of 9. All right, so that is the first measure of dispersion. It really can't get any easier than this. You just take the highest, subtract the lowest, okay? Now, the measure that we're going to spend much more time on in this section is standard deviation. There's a lot more going on here, okay? You can see from the formula there's a lot more going on here. So the standard deviation is found by determining how much each data item differs from the mean, okay? So the first thing I really want to point out is when you're talking about the standard deviation, this is dependent on all data items. So each data item is going to be part of the calculation, which is different from the range. Remember, from the range, we're only looking at the highest and lowest data items. Here, we look at every single data item. They're all part of the calculation, okay? And basically, this tells us, on average, how much does each data item differ from the mean. Now, that's kind of a rough definition, but ultimately that's what we're looking at. We're looking to see on average how much does each data item differ from the mean, okay? And so we do have this formula here, which is kind of a lot. So we have the standard deviation. Now we have that E symbol again. You saw this in a previous section. So when did we do this? We did this back when we were talking about something in maybe the previous chapter. Anyway, you've seen this symbol before. So we have E, which is the summation symbol. Sorry, I ran out of room. Summation symbol, all right? And it just means add them all up. All right? So we have that symbol again here. So we're going to be adding stuff up. And what we're going to do is we're going to take the data item, each individual data item, we're going to subtract the mean, and then we're going to square it, and then we're going to add those up. So we take each data item and subtract the mean. Square this value. Add them all up. That's what that summation symbol is for. All right, so that's kind of the first big step. So you do have to start by calculating the mean of your data set. And then one at a time, you're going to take your data item, you're going to subtract your mean, and you're going to square the result. You then add all of those up, and then you want to divide by the number of data items. We're going to call that n minus 1. So if you have 10 data items in your set, you're going to take 10, you're going to subtract 1, and that's what you're going to divide by. And then finally, take the square root. And that is your standard deviation. Okay, so that's kind of like what we're doing. Let's talk about all of the symbols that we see in this formula. So we have the formula kind of written out in words, and then in this little column we have left, we have the formula written out symbolically. So lowercase s is standard deviation. We already know what the summation symbol is. X represents each data item. Hopefully, you know from the previous section, X bar is just your mean. So we call this X bar, and it stands for the mean. And then N is going to be the number of data items. Okay, this is not a hard calculation. You're literally calculating a mean. You've already practiced that. You're doing a little subtraction. You're squaring stuff. You're dividing by a number, and then you're taking the square root. The issue is it's just kind of tedious because if you have a data set that has 50 data items, you've got to subtract the mean from 50 data items, square each of those individually, add them up, and then divide, okay? So doing the standard deviation by hand is absolutely possible. It's not super, super realistic if you have a large data set. If you have a data set of more than like 10, you would definitely want to go to a calculator, which I will show you how to do later in this video. But for small data sets, we can do this by hand. So let's practice, okay? So the first data set we're going to look at is pretty straightforward, okay? We have that same data set that we just used to calculate the range. We've got the data items 4, 2, 11, and 7. So just so you remember, standard deviation, you take each data item, X, you subtract the mean, which is X bar. For each of those, you square them individually, and then you add them up. And then you want to divide by n minus 1. So here's what I do. I set up a table. So I have my data item. So I have data items 4, 2, 11, and 7. I have my data item minus the mean. And then I take the data item minus the mean, and remember, we have to square it. And those are the 3 columns in my table, okay? Now, the first thing we're going to do is we're going to the side calculate the mean. You have to have the mean in order to do these calculations. So X bar, remember from the previous section, you take all of your data items and you add them. And then you divide by the number of data items in your list. We have 4 data items, so we divide by 4. So really quick, let's see here. We have 11 plus, well, we have 4 plus 2 plus 11 plus 7. So we have 24 divided by 4. So X bar in this case is 6. All right. So keep that in mind. All right. So now we're going to go through, and each data item, I'm going to first just subtract the mean. So my first data item is 4. I want to subtract the mean of 6, and I get -2. My second data item is 2. I subtract the mean, and I get -4. Third data item is 11. I subtract 6, the mean, and I get 5. And then the fourth data item is 7. I subtract the mean of 6, and I get 1. Okay? Now, in the next column, I'm going to take each of those values from the middle column, and I'm going to square them. You must use parentheses here. Okay, this is a really common mistake math students make. They just try to square it and they forget about the negative. We do need the negative in parentheses. I'm going to go ahead and square the bottom 2 in parentheses, even though they're positive, but the ones that have a negative, you have to use those parentheses, don't forget. So we're going to square each of these, and -2 in parentheses squared is 4. -4 in parentheses squared is 16. 5 squared is 25. 1 squared is 1. And then I'm just going to add all of these up. All right, so let's see, we get 4 plus 16 plus 25 plus 1. So we get 46 right here. Okay, now what we need to do is we need to figure out how many data items did we have. Well, we have n data items, which is 4. We need to figure out what n minus 1 is. That's just 3. Okay, so we're doing this part of the formula right here, the n minus 1. All right, and now let's plug everything into this formula right here. So this right here is the sum of your x minus x bar squared. So that's going to go into the numerator. So 46 is my entire numerator. That's what this table finds out or determines for you. The denominator is n minus 1. N is 4 because we have 4 data items. We subtract 1, we get 3. And then I'm just going to go to the calculator and I'm going to type in exactly what you see here. So if you want to see it in the calculator, we would go second, and then the x squared button will type in a radical symbol. So you hit the blue second button, and then this button that has x squared, that'll do the radical. And then we just want to type in 46 divided by 3. We're going to round usually like 1 or 2 decimal places. For this example, we're going to round to the nearest hundredth, so that's 2 decimal places. So if I round here, I would go 3.92. Okay, so 3.92 is the standard deviation for this problem. So we'll go approximately 3.92. So this means on average, these data items differ from the mean by 3.92. All right, so that is how you calculate the standard deviation by hand. It's tedious. None of the steps are difficult. It's just a lot of steps, a lot to keep track of. So you need to be very neat and organized. Let's do another one by hand, and then we will go to the calculator. I'll show you how to do all this in the calculator. So next up, we have, how many more examples? Just 2. Let's do both of these by hand just for the sake of practice, and then I'll show you how to do them on the calculator, and we'll practice all 3 on the calculator. Okay, so first up, it says find the standard deviation for the following data items. Okay, we're going to round again to 2 decimal places, so we're going to round to the nearest hundredth. But first, we need to calculate the mean. Okay, so remember, we have 73 plus 75 plus 77. Oh, I'm going to run out of room. Hold on. So we have 73 plus 75 plus 77 plus 79 plus 81 plus 83. We need to divide by how many data items we have, which is 6. And if this is easier, we can just go to the calculator. So make sure you've written this down. So we can go to the calculator. All right, now I want to remind you all, there's a way to get your calculator to just input data for a fraction. So it'll have like a specific numerator and denominator. So you go alpha y equals, option 1 is the fraction. There are other ways to do this depending on your calculator, but this is kind of like just the most generic. So for the, let's see, let me flip the page on my paper copy. For the numerator, we had 73 plus 75 plus 77 plus 79 plus 81 plus 83. And then for the denominator, we had 6. And it just so happens our mean is 78. So we're going to go back to the problem. There we go. So our mean here is 78. Remember, that's going to be part of this calculation. So we start with our data items. I'm just going to list them out vertically. We have 73, 75, 77, 79, 81, 83. For each of those, we're going to take the data item and we're going to subtract the mean. So 73 minus 78 is -5. 75 minus 78 is -3. 77 minus 78 is -1. 79 minus 78 is 1. 81 minus 78 is 3. And 83 minus 78 is 5. And then in the next column, I like to square them. So we have -5 squared is 25. -3 squared is 9. -1 squared is 1. 1 squared is 1. 3 squared is 9. 5 squared is 25. And then I'm going to add all of this up. And let's see what we get. So 25 plus 9 plus 1 plus 1 plus 9 plus 25. And we get 70. Okay. So far, we've got, let me do it over here. We've got the sum of x minus x bar squared is 70. Now we need to figure out the denominator of the formula. So we need to know what n is. Remember, n is the number of data items we have in the list, which is 6. N minus 1 is 5. So just for the sake of a reminder, the formula is the sum of each data item minus the mean squared divided by n minus 1. So for us, it's going to be 70 divided by 5, and then we're going to take the square root of that. So let's go back to the calculator. So we would go second x squared, that's going to be the radical symbol, and then we would just do 70 divided by 5. And then hit enter. And again, we'll go 2 decimal places. So we'd say 3.74. So 3.74 would be our standard deviation here. So on average, the data items differ from the mean by 2.74. Okay. All right, let's look at the last example by hand, and then I promise I'll show you how to do this on the calculator. All right, so last up, we have the data items 40, 44, 92, 94, 98, and 100. And just for fun, let's go to this previous example that we had right here. If we were to look at the range, just kind of for the sake of practice, the highest data item in this list was 83. The lowest data item was 73. So the range here would be 10. Okay, so keep that in mind. Let's look at the next data set. All right, so right here, we have the data items 40, 44, 92, 94, 98, and 100. So again, just for the sake of practice, the highest data item is 100. The lowest data item is 40. We subtract, we get a range of 60. Okay, now let's look at X bar, or the mean. So we'll calculate this. We'll use the calculator in just a second, but remember, you add up the data items. And then you divide by how many data items are in your list. Again, we have 6 data items in the list. Okay, so we can go to the calculator. Make sure you had that written down before I switch screens without telling you. All right, so again, I'm going to do alpha y equals, that just presents kind of like a template for a fraction. In the numerator, whoops, there we go. In the numerator, we have 40 plus 44 plus 92 plus 94 plus 98 plus 100. And then the denominator, we have 6. And would you look at that? Again, we have a mean of 78, okay? So let's go back to the worksheet. All right, so we have a mean of 78 again. So if we compare this to the previous data set, you can see that we have the same mean. Both of these data items, they have, or data sets, have 6 items. They both have a mean of 78, but you can see the range is wildly different. So in the first example that we did on this page that you're looking at, we have a range of 10, but we have a standard deviation of 3.74. That just means these data items don't spread out very far. You can see on average, they differ from the mean by 3.74. Without calculating the standard deviation, if I were a betting woman, I would say that the standard deviation for this data set is going to be much, much higher, simply because the range is so much higher. Remember, the previous data set, everything was in the 70s, and they had a range, or 70s and 80s, and there was a range of only 10. Here we have data items in the 40s and the 90s. There's a much bigger spread. So we would expect a much larger standard deviation. Okay, so let's get to it. Remember, for the sake of just a reminder, standard deviation is the square root of, you take each data item, subtract the mean, square it, and then add them up. And then we divide by n minus 1. Okay, and that whole thing is the square root. There. All right, so we start with the data item. This is just how I organize it. You might find that you have something that you like to do a little bit better. That's fine, but do be very neat and organized if you're going to do a standard deviation by hand. We have 40, 44, 92, 94, 98, 100. I'm then going to take each data item and I'm going to subtract the mean. Whoops. So we have 40 minus 78, which is going to be what? Negative 38. We have 44 minus 78, which is negative 34. Negative 34. We have 92 minus 78, which is 14. (94) minus 78, which is 16. 98 minus 78, which is 20. And then finally 100 minus 78, which is 22. Okay, now what we want to do is we want to square each of these data items. So we have x minus x bar squared. And then once we get those squared, we're going to add everything up. So we're going to get some pretty big numbers here, so just brace yourselves. So negative 38 squared is 1,444. Negative 34 squared is 1,156. 14 squared is what, like 296 or something? 196, I was way off. 16 squared is 256. 20 squared is 400. And finally, 22 squared, we get 484. And you want to add all of these data items up. So let's see, we get 1444 plus 1156 plus 196 plus 256 plus 400 plus 484. I'm going to add them up again just to make sure I don't make a mistake. And I get 3936. So far, if we look at just the sum of the data items minus the mean squared, we get 39, 36. We need to figure out what n and n minus 1 are. So n is the number of data items in your set. We had 6 data items here. So that tells me that n minus 1 would be 5. So for the standard deviation, we're going to fill in what we have. The numerator is 39, 36. We want to divide by 5. Let's go back to the calculator really quick. So again, alpha y equals pulls up that fraction template. Well, I don't want the fraction template right here. So let's do second x squared, and then I don't really need the fraction. So we'll do 39, 36 divided by 5. And if we go 2 decimal places, we get 28.06. So 28.06. We'll do the approximately equals. And that kind of fits. Remember, we had a much larger range for this data set, even though we had, that's my dog, I'm so sorry, she's been pretty wound up today. So the previous data set, we had a range of just 10 and a standard deviation of 3.74. This data set, even though it has the same mean, it had a much bigger range, and it should have a much bigger standard deviation. This means on average, these data items differ from the mean by 28.06. That doesn't mean each individual data item differs from the mean by 28.06. It's just on average, that's approximately how much they would all differ from the mean. So there you have it. That is calculating range and standard deviation. So again, the range is super easy. You just take the highest minus the lowest. Standard deviation, none of the individual calculations are difficult, but there's just a lot of them. So it's a little bit more involved. Okay. Now, as promised, we're going to look at these data sets on the calculator. So we're going to go here. So on the calculator, this is that first example that we did. Okay. So here's your data set in case you're kind of lost finding it. All right, so we're going to do the standard deviation, but I'm going to show you very specifically how to do this on your calculator. It's a little bit of a process, but it's going to be a big time saver. So what I encourage you to do is in your homework, try the standard deviation by hand and then check yourself with your calculator. Okay, on your final exam, just use your calculator, okay, for the sake of time. All right, so let's go back to the calculator. So this is not going to make a lick of sense unless you watched the previous videos on how to do the mean on the calculator. I'm pretty sure in that video I show you how to do the mean in the calculator, but if not, just pay close attention. I don't know that there's a way to make this bigger. Well, it kind of makes it bigger, but it's going to go off the screen a little. I don't think that's going to work. Yeah. All right. I can't really make the calculator bigger. This is just a free online version, so it's not the best setup I've ever used. But anyway, so what you want to do, if you're trying to calculate different measures on a set of data, you have to first input that set of data, okay? So if you look at your calculator, beside this circle of direction buttons, there's a button that says Stat, okay? When you go to the stat button, it allows you to input a set of data. So the very first thing you want to do is input your data by going to edit. So there's 3 different menus here. There's edit, calculate, and then tests. You would just go right and left to switch menus. All right. We just want to input a data set. So we want to just edit. Okay. So hit enter. And then you should have L1, L2, L3, L4, L5. What's going to be weird here is if you have an issue with your calculator, I'm not available in person to help you like I would be in class. So it might be a situation where you have to join me on Zoom and we have to kind of troubleshoot some stuff the best we can via Zoom. And if push comes to shove, I can come to campus at some point and meet up with some of you if you have calculator issues. But you should, when you hit the stat button, so again, we hit stat, the first menu, edit, should be highlighted, and we just want to choose option 1, and you should see this starting with L1. If you see it not starting with L1, that would be a time to reach out to me. So you want to input your data set in L1. So we're looking at that data set. That was just 4 data items. It was 4. So type in a 4 and then hit enter. 2, enter. 11, enter. And then 7, enter. Okay, so you got your whole data set in there. You want to double check it, make sure you typed in everything correctly. And then you just want to go back to stat right here And now we want to calculate something. So we want to hit the right arrow in this little circle of directional buttons. We want to hit the right arrow so the calculate menu pops up. And you want to choose 1-var, which stands for one variable, stats. So one variable statistics. So choose option 1. That just means you're looking at one list of data. All right. This is another area where your calculator might differ depending on how old your calculator is or which version of the calculator you have. If you see this screen, L1 is where I put my data set. If yours says anything other than L1, like L2, and you put your data set in L2, you need to change this to say L2, okay? But for now, my data is in L1. I'm going to keep it in L1. So I hit enter until I get down here to calculate, and then I hit enter again, and it's going to pop out some information for me, okay? Now, the very first thing it shows me is X bar, which is the mean. So let's go back to that data set really quick. And remember, we calculated the mean by hand, and sure enough, we got the mean of 6, okay, which is exactly what the calculator just told us, okay? If you go down, it has this situation here where it adds up the x's, it adds up the x squared. Don't worry about those. And then we have SX. SX is the standard deviation, okay? And it's 3.92. So if we go back to our data set, well, when we calculated the standard deviation by hand, we got 3.92, and we got exactly the same thing on the calculator. So it does not take a lot of work to do the standard deviation on the calculator, okay? So you just calculate the standard deviation on the calculator, bam. All right. Now, I do want you to know how to do this by hand. So again, in your homework, at least the first couple, try them by hand and then use the calculator. If you're pinched for time, use the calculator. I will say you're doing yourself a disservice if you don't know how to do it by hand, but there you have it. All right. Let's look at the next example. So the next example was that data set with the mean of 78 and a range of 10. Okay. So we're going to go to the calculator and we're just going to repeat what we did for the previous example. So I want to go to stat and I want to edit a list. Now, I don't want to start a new list. I just want to get rid of the old stuff. And a lot of people will just type over the previous list. I don't encourage that because sometimes you can miss a number and it'll mess up your whole data set. So what I do is I like to erase this. So I go up until L1 is highlighted, and then I hit clear. It clears the contents of the list. It doesn't look like it at first, but once you hit the down arrow, it clears it out. So I'm going to type in a couple of random numbers. All right, so let's say this data is in your calculator. You want to clear it again. You go up until L1 is highlighted, and then you just hit clear right below the little circle wheel. And then when you hit the down arrow, the data's gone. Okay, so it's really easy to clear out an old list. All right, so let's see. For this list, this is that second example we did. We have the data items 73. So 73, enter. 75, enter. 77, enter. 79, enter. 81, enter. 83. All right. So we've got our data set. Double check it. Make sure you typed everything in correctly. And then you want to go back to the stat button. But this time we want to calculate something. So we're going to hit the right arrow in this little directional wheel of buttons. We're going to hit the right arrow until calc is highlighted. We want to go to 1-var stats. Hit enter. Again, depending on what list you put in, you need to make sure that list is listed here correctly. So L1 is where I put mine. And then I'm going to hit enter until it gets down here to calculate. Once calculate is highlighted and you hit enter, it's going to actually spit out the data. Notice here it says X bar is 78. And then if we skip the next two, the sum of the x's we don't worry about, the sum of x squared we don't worry about. Instead, we want to look at SX. And if we round to 2 decimal places, we get 3.74, which is exactly what we got when we did this by hand. So notice we had the mean correct and we had the standard deviation correct. So again, it does not take a lot of time to do standard deviation on your calculator. Now, to understand what you're doing and to understand the whole purpose behind standard deviation, knowing how to do it by hand is powerful. Check yourself with a calculator for sure. All right, finally, let's do the last example just so you can see it on the calculator one last time. So we're going to look at this data set, the data set that also had 78 as the mean, but had the much larger range of 60. So let's go back to the calculator. All right, so let's go to stat. We want to edit a new list. So we're going to go to the edit menu. The first option is edit. So hit enter. And I want to clear this out. Okay. Typing over it is kind of like risky. Okay. Because you may miss something. So I'm going to go up until L1 is highlighted. I'm going to go down here to the clear button. I just want to clear the contents and then hit the down arrow. Contents are gone. Okay. So for the new data set, we have 40, 44, 92, 94, 98, and 100. Okay, so double check your list, make sure you type everything in correctly, and then go right back to that stat button. But this time we want to calculate something, so we're going to go to the right-hand side. We're going to go over to the calc menu. I want one var stat, so you can either hit enter or hit the 1 button. My information is in the list L1, hit enter. And look, we got the standard or the mean rather of 78. We skip the next 2 data items or the next 2 entries. And then finally SX, we get 28.06, which if we go back to our worksheet is exactly what we calculated. All right, so there you have it. This is how to calculate measures of dispersion. Remember, the range is a very rough calculation. It only depends on 2 of your data items, but it does give you a very quick picture of what's going on. Standard deviation is much more involved. It does depend on all data items. It tells you on average how much each data item differs from the mean. It is not difficult to calculate. It is definitely tedious. Okay, I do encourage you to practice at least a couple of these by hand, and then certainly use your calculator to check your work. All right, I hope this all went well. Definitely reach out if you have issues with your calculator. All right, take care.